So it's long time no talks or reading in English on my channel. So today I would like to share my trip which I usually am study on the algorithm and data structure. So I just want to read my English which I share you on the screen. So I hope you guys enjoy doing that. Let's get started. Okay. Ah, okay. What you need to know? You will need to know basics algebra because studying this book in particular takes this function fx equal to x times 2. What is f5? If your answer is 10, you are set. Add, additionally, okay, additionally, this chapter and this book will be easier to follow if you are familiar with the programming language. Or the example in these books are in Python, which I don't know much about Python. I know JavaScript. If you don't know any programming languages and want to learn one, choose Python. This is great for beginners. If you know another language like Ruby, you will be fine. I think JavaScript will be also fine. Okay, first chapter we're gonna learn about binary search. Okay, what is binary search? Suppose you are searching for a person in a phone's books. What's an old-fashioned sentence, right? Yeah, like a long time ago, when we want to find someone's phone number, we have like a yellow books, right? And then we open the books to find the numbers, right? It's like an old version, but kind of now we don't use that because we have our phones, and then we just fire phones, right? And all going to the internet, right? So just searching online on the internet is just very easy than long time ago. Okay, their name starts with K in a book. You could start at the beginnings and keep flipping page until you get the case, but you are more likely to start at a page in the middle because you know the case are going to the near the middle of the phone books, right? We count like A to Z and then we know where is K is, right? So we just open the case is the middle of the books. Or suppose you are searching for a word in a dictionary and it starts with the O. Or again, you will start near the middle. Now, suppose you log on to Facebook. When you do Facebook, have to verify that you have an account on the site. So it needs to search for your username. It is database. Suppose your username is what's that? Camelondon. I don't know how to pronounce that. Facebook could start with the S, and search for your name in database, right? So let's say your username is Command Garant. Facebook could start at A as at the search for your name, but it makes more sense for is go to is to begin somewhere in the middle. Hmm. This is a search problem, and all these cases used to same algorithm, use the same algorithm to solve the problems. Binary search. Binary search is an algorithm. It's input in a sorted list of elements. I will explain later why it needs to be sorted. If an element you are looking for is in that list, binary search tree return the position where it's located. Otherwise, search tree will return no. Okay, let's say a picture. Yeah. For examples, okay, this is like a name, right? Commercials industry, and when there is industry, this is all okay. Okay, one is looking for companies is in a phone books with binary search tree. This is an example. So here are an example of how binary search works. I'm thinking of number between 1 to 100. You have to try to guess my numbers in the fewest try possible. With every guess, I will tell you if your guess is too low or too high or correct. Suppose you start guess like 1, 2, 3, 4. Yeah, how it work. Let's say when you guess, okay, 1 is too low, 2 is too low, all right? Okay, next. And it's 7. 7 is too low. So a bad approach number giving. Yes, you just count 1, 2, 3, 4, 5. This is simple search. Maybe stupid search would be a better term. With each guess, you are eliminating eliminating only one number. If your number was 99, it could take 99 guess to get there. Okay. Okay. A better search. Yeah, better search. Start with 50 because you have 1 to 100, right? You start in the middle, you get 50. Okay. And then I say it's too low. It means we're gonna count from 51 to 100. So we cut all out from 1 to 50, right? Two rows, but just eliminated half of the number. Now you know what 1 to 50 are. So two rows, so make it. So you get 75. So in the middle of between 51 to 100. So you get again 75, and then it's too high. It means, okay, from 75 to 100 is not right. So now we know the number should be between 51 to 74. Okay, so if 75 is too high, but again, you cut down half of remembering number with binary search, you guess the middle numbers and eliminate half of the remaining numbers every time. Next, you get 63 halfway between 50 to 75. And is it still too high? And then next get you get 57. This is binary search. You just learned your first algorithm. Yeah, how many numbers you can eliminate every time. Okay, from 100 times, you've come to 50 times, 25, 13, 7, 4, 2, and 1. Yeah, just 7 steps instead of 100 steps, right? Oh, sorry. Come back, come back. Whatever, but whatever numbers I'm thinking of, you can get in a maximum of 7 guesses because you eliminate so many numbers with every guess. Suppose you are looking for a word in the dictionary. The dictionary has 250,000 words. In the worst case, how many steps do you think each search will take? Simple search, simple search will take like 250,000 steps, right? But for binary search, to make it half and then count on. Okay, like in this book set, simple search could take 240,000 steps. If the word you are looking for is the very last ones in the books, with each step of binary search, you can cut up the number of words in half until you until you are left in with only one word, which you find. Okay, next one. Okay. Mhm. So binary search will take 18 steps. A big difference in general for any list of n. Binary search tree will take logs n steps. Okay, binary search tree will big O notation, right? So we talk about our term of big O. So binary source will be log n. Oh, okay, because we make it half, not n times square. Okay, so it's log n. Log n is better than O. Uh, log n is better than O of n. Okay, from what I understand, the first, the best one is O of 1, right? And the second one is O of log n. So O log n is better than O of n. Okay, binary search will take logs n steps to run in the worst case. Whatever simple search will take n steps, O log n. Okay, algorithms, you may not remember what okay, logarithm, okay. You may not remember what logarithms are, but you probably know what exponentials are. Logs 10. 100 is like asking how many tens do we multiply together to get 100. The answer is 2, right? 2 because 10 times 10. So logs n 100 is 2 logs are the flips of exponentials. Okay, so okay, 2 of n log exponentials. Okay, log are the flips of exponential. In this book, when I talk about running times in big O notation, explain it, explains a little bit a little later. Logs always means logs too. When you search for an element using simple search, in the worst case scenario, case you might have to look at every single element. So for a list of 8 numbers, you have to check 8 elements at most. For binary search, you have to check log n elements in the worst case. For a list of 8 elements, log 8 equal to 3 because 2 power of 3 is equal to 8. Okay, mean log 8. So for a list of 8 numbers, you would have to check 3 numbers at most. Okay, so if we have 100, we're gonna call log 100, right? And then 2 times how many? Okay, log 10 is okay. Huh. A little bit confused for me. It's kind of like a math problem too, so it's more clear to read this book. Okay, so for other numbers, for a list of 1024 elements, we call for binary search. The big O notation is gonna be logs 1024 is equal to 10 because 2 times power of 10 is 1024. Mm. For a list, exponential. So exponential is like a 2, right? 2 times how many times? Say 2 logs are flip. Okay. Uh, you would have to check one at least not more than 10 members at most. I will talk about logs terms a lot in this book, so you need to understand the concept of algorithms. If you don't, Khan Academy has a nice video to make it clear. Okay, so let's move here. Okay, binary search only works when your list is in sorted order. Okay, remember. So to search to use binary search, uh, in our algorithm to solving problems, the number should be already sorted. Okay. Order for example, the name in the phone book are sorted in alphabetical order. So you can use binary search to look for a name. What would be happen if the names weren't sorted? Let's see how many let's see how to write binary search in Python. I don't know in Python. Okay, the code symbol here use array. If you don't know how array works, don't worry. They are covered in the next chapter. You just need to know that you can store a sequence of elements in a rows of consecutive bucket called an array. The buckets are numbers starting with 0 our first bucket is the position 0, and second is 1, 2, 3, 4. The array is start from position 0. The binary source function will take a source array. Okay, it have to be a source array, and in item of the items, uh, and an item. If the item is in the array, the function return is position. You will keep track of what part of arrays you have to source through at the beginnings. This is the entire array. Okay, yeah, arrays have to source. Okay, okay. Each time you check middle array, so how you find first you find the middle of array, right? Because we use binary search to do so. Array is already sorted, so we find out which is the middle position in this array, and we want to guess, right? So if the guess is too low, you update left, right? Row and add from the mid position. Okay. And if guess is too high, you update the high, like by decrement. Okay, this code I'm not gonna read all here for you. Okay, so that's it for today. I going to do exercise for this one in terms of searching binary search tree. So next chapter, I will make another video to read another things. So thank you for watching. See you next one. Bye.